Have you been feeling stuck? Like you haven't done anything cool with your Jetson or a Nano Super? I'd run some LLMs, but I still felt like there was more I could get out of the device. That's when I found out about social robots. I'm struggling to see how the moon landing would have anything to do with this. Side effects may include laughing, having a great time, and becoming better at programming. Thanks to Social Robot, I now feel like I've used my Jetson to its full potential. So for today's video, we're going to be using the Jetson or a Nano Super to build this open source social chat robot. Now, obviously, there are a lot of other things that go into actually building a robot, and this is my own design and something I've had for a couple of years now, and it is going to be completely open source, so anyone can download all of the files here, print them themselves. There will be a parts list to actually purchase all of the additional parts needed. Beyond that, if you want to just run the actual chatbot software that we're going to be building today, you don't need a robot for it. You can just use it with a computer monitor, basically, and have a fun little low latency offline chatbot. But the whole fun point of this is that we can actually go ahead and put it on a social robot, something that truthfully is not still very accessible at all. So I wanted to just really properly open source these, but use them with something that is rather potent in an edge and offline capable device such as the Jetson or a Nano Super. So we're going to start by just going through the actual installation steps on the Jetson itself, and then following that we'll go through some robot specific considerations for anyone who wants to build one of these themselves and actually get it running like that. Now, I will say that this is free, open source, and will be available on GitHub. However, there are a few of these that I will put for sale on my own personal shop website, which is ominousindustries.com. So if anyone just wants to buy a BYOJ or bring your own Jetson kit, where basically it will come with everything except the Jetson, that is also going to be an option. So with that, let's get into the installation steps and tutorial. So to begin our installation process, it is fortunately quite simple, and just to make sure that everything here is replicatable on an unmodified Jetson system, I am using a freshly flashed version of Jetpack 6.2 that was just downloaded from the Jetson AI Lab website, which has all of the information on that, as well as flashing the SD card and things of that sort. Also, I will link in the video description my full hour or so long tutorial on setting the Jetson up, just so if you want to be able to start from the point we're at here, you can follow along with that, and then this will make a lot more sense if you have just received your Jetson and are yet to set it up. But with that, we're now going to jump into actually getting the dependencies and the environment set up for this chatbot to actually function, keeping in mind that it is not a requirement to have a very cool and awesome physical robot to actually place this in. It will function just as a chatbot on any like random desktop screen or whatever you want to do. So with that, first step is just basically going to be to go to the GitHub repository for this, which I have creatively just named Robotest, at least for now. Perhaps will change in the future. But with that, we can basically scroll down right here and see a little bit of pertinent information about the project. But beyond that, we have the installation steps right here. And if we scroll all the way down, we can see that there is a fairly light amount of work to do here. So fortunately, this will happen rather quickly. So the actual chatbot loop here is explained fairly simply in this little overview snippet where we talk about the actual pieces that go together to create this project, such as WebRTC-based voice activity detection. So this is, of course, what gives this the ability to actually know when you're speaking and begin to listen to you. Without that, and in the past, it was very clunky because you ideally would just need like an actual physical button to begin recording, and then you would let go of it to stop. And it was just very clunky and old-fashioned and cumbersome. So having voice activity detection is definitely worth the immersive experience, I suppose, could be said. Next up, we have the text-to-speech that we're going to be using called Kokoro-Onyx, or whatever you want to refer to that as. It's Kokoro. It's very lightweight. It has a few different selectable voices for different styles, different locales, and things of that sort. And most importantly, while it is not the most immersive thing in the world, it is lightweight, and that is a consideration on the Jetson because you need something that won't really take up a lot of the available power, being that there's not a ton, especially when thinking about running like machine learning things or something of the sort. Finally, we need the thing that actually does the speech to text transcription. meaning that when it hears us speak, it actually needs to transcribe what we say into text so that that can be sent to the LLM for it to understand. And that is something called faster whisper. And again, this is just like the whisper transcription, which you may be familiar of, but it is optimized to work better on low resource and power constrained devices, such as this Jetson. Now, obviously, the final piece of the puzzle here is actually the LLM that we're going to be able to speak with. And for that, we're just going to use Ollama as the backend. And for this specific implementation, I am opting to use probably one of the most lightweight but usable models in existence currently, which is Gemma 3 from Google, but the 270 million parameter variant of it. So that is an extremely lightweight model, and we will actually be running that at a quantization as well. So it will take up about, this is probably the smallest but most lucid model that currently exists that we could actually chat with back and forth here. And obviously it is quite simple to actually change the model we're using, and you could use like an uncensored model or something if you wanted to, which would be recommended, depend on one's area of interest. But with that, that's basically just a simple kind of tech stack overview of the project, and now we can safely go ahead and actually begin these installation steps. So first off, all we're going to do is really quite simply just copy this entire block of commands right here and paste it into the terminal. And you can just kind of think about this as like installing some operating system dependencies or something like that that will allow some of the aspects of this program to actually function. So you may see here like, okay, well, this says sudo apt install, but then later down here we're doing pip install, and there is a difference in these. It's probably like beyond the scope of a simple like lighter tutorial, but just keep in mind that like these are operating system prerequisites. So these are things that the actual like operating system would require to actually run some of the features of this program, where if we scroll down here and see the pip installs, these are like Python dependencies or Python packages that will kind of help our Python script actually work. And that is, again, probably like a rather lackluster and non-scientific explanation, but I suppose for the time being it is reasonable. Now, fortunately, that did not take very long, and we can move on to step 2, where we're basically going to clone this entire GitHub repository and then download it onto our local device. So to put it quite simply, it's essentially like kind of downloading all of these and placing them on our local device and then navigating into that specific folder which contains all of these cloned items. So when we do that, we will see right here that we do now have the robotest directory on our device, and as denoted by kind of this little snippet right here, we are now actually in said directory. So if we type ls right here, it will list the files contained within this directory, which we can see are the same as what we see right here. So that just kind of like clones this project so we can actually work with it locally on our local machine. Next step is basically to go ahead and create a virtual environment from with which we can run all of these scripts and install all of the dependencies and things like that. Keeping things in a virtual environment is best practice because oftentimes different projects may have slightly different required versions of some of their dependencies, and if you have all of the dependencies installed in one central location, some of those version mismatches can cause some significant issues. So it is just best practice to go ahead and do a virtual environment. I will just do these all kind of separate one by one real quick. So first and foremost, we're just creating the virtual environment from within this robotest subdirectory. Oh no, that's okay. So I'm going to fix this command. It will create this virtual environment from within the robotest subdirectory. Right now, it did just create it in a robot directory, which did not previously exist. So it would have just created said directory. I suppose this is okay too. This is why we do things live, just so we learn. And now we're going to activate the virtual environment, and we will notice that right next to here, we will then see in parentheses venv, just like that, to denote that we are now actually within our virtual environment. So anything we install here, like with these pip commands to actually install these Python packages, will go ahead and be contained within our virtual environment. And in keeping with that, our next step is to just go ahead and actually install all of the requirements for this specific project, which will go ahead and happen right now. And we can see some of these will be familiar just based off of the actual overview right here, such as Kokoro, Faster Whisper, and things of that sort. You can also see the specific requirements. There's not too many of them right here if you actually click on the requirements.txt. So the next step is one that is probably going to be slightly modified by the time anyone actually goes to play with this, where basically we actually need to manually place a face image and a mouth image in this directory. Truthfully, I am going to just upload the default ones that I've been using for demonstration purposes here. So basically, when you go ahead and actually clone this and install it on your Jetson, those files will be provided there, so you won't really necessarily have to worry about this step. So for time being, let's just pretend we kind of skipped this, as it won't necessarily need to actually be present in the finalized version of this install guide. So skipping on and moving to the next thing, we are actually going to go ahead and install Ollama, which is what will handle the LLM running and actually being able to just like kind of host or interact with the LLM, to put it somewhat simply. First and foremost, we can just use this command to install Ollama, and I am just going to clear my terminal there, as sometimes it gets very verbose with the mass amount of text that is actually kind of everywhere. So we can see right here that Ollama is now going to install, which shouldn't take very long. And upon the completion of this install, we will see something like downloading Jetpack components. So it's really cool because it actually kind of automatically can identify, oh, okay, it's like a Jetson, so I'll download the additional components to actually work with the Jetpack operating system. And now we should soon see the downloading Jetpack 6 components here, which doesn't take very long at all. And once this is done, we get just kind of like a nice little bit of information about everything having gone successfully. And the next step is one of the most fun parts here, where we can actually go ahead and download our very tiny LLM to begin the process of being able to interact with it through speech. Now, you can see right here, this is a very quick download, relatively speaking, for an LLM, just because of how small this model is. And something cool is actually when this is finished downloading right here, we will actually get the option to kind of speak with it, if you will, just by typing to it. So I always like to do that, even if it's not necessarily required, just to kind of make sure like everything's working fine. So, hey, bro. And then so it just wrote back, hey, with like a wave emoji. I noticed the Google models seem to very much like using emojis in their responses. So you can do that or choose not to. It doesn't really matter. And then you just type / and bye, which will go ahead and kind of just exit like the Ollama process, and we will no longer be chatting with said model. Now, our next step is basically to go ahead and actually be able to run this, but there are a few things I would like to mention first and foremost, as they do differ in the kind of execution depending on whether or not you will be using a robot or you will just be using the Jetson plugged into a display or something like that. So I personally just have a USB microphone like this plugged into the Jetson, and for the actual audio out, I am just going to have it play through the speakers in this computer monitor right here, being that I want to first showcase this just running on a computer monitor without any of the fancy high-tech robot stuff. So honestly, I find there are ways to do this through the command line and things like that, but they're rather cumbersome. Really, the best way to go ahead and make sure your audio settings are correct is to go up here into the top right and just click on any one of those 3 icons, and then from the drop-down menu that appears, click Settings. Once that opens, we're just going to go in the left-hand menu right here and go to Sound, and then we will just select our output first and foremost, where I want to use the HDMI display output because that is just the speaker monitors for this computer monitor, the speakers of this computer monitor that I'm using. And to make sure things are working, you can click Test and click one of these. I don't even know if you'll be able to hear that because of how quiet the speakers in this monitor are, but it will just play these sample sounds so you can make sure that everything is working. Following that, we see that there is an input section right here, and you would expect this to actually be showing some level of activity, being that I am speaking fairly close to this microphone right here. So we do need to manually select our microphone as well. So if we click the drop down here, I will see my microphone right here. And now, hey, you can see that the volume or the activity bar is actually properly working. So really it is quite simple, especially if you're using this through like just a regular computer monitor to set up all of the audio considerations. Now, because I have not yet updated this repository to actually have the default included images in it, I do actually need to just go ahead and find some like sample PNGs or something like that. So I will just click on Bob images. These are for Bob the sentient washing machine, and really I can just download any single one of these. We have the cute little washing machine face right there. So I will just rename this And maybe this will be good to see, because if you want to put your own image in, you can definitely do that. So I have a custom face image right here, which we definitely do. I'm just going to bring it home. I'm going to copy this and paste it into the RoboTest directory, which is the directory which contains our little kind of chatbot program. We'll paste it in right there. And then I will now rename this to mouth, since we need a face and a mouth PNG photo. And the mouth will just get scaled kind of procedurally, so it will scale up and down like depending on the actual speech activity of the robot when it's speaking. So it's just simple, but like a bit more immersiveness comparatively, I suppose could be said. So with that now, we are all set to basically go ahead and run the full application here, which is quite simple. So all we have to do is just do python main.py, and the other things right here we can kind of omit for the time being, as I will show some different steps for if we're actually going to be using this from within the robot. And basically, you can just minimize that. We'll do python main.py, and keep in mind on the first run, it will take a little while for everything to go ahead and actually happen, because we do actually need to download some of the models for our text-to-speech, our speech transcription, and things like that. Well, I didn't mean to fully minimize this, I just meant to move it. So we can see right here, that's what's happening, is this is going ahead and downloading some of the required things for our text-to-speech and our speech-to-text. And now we can see that it will begin to listen, and once I stop talking, it will show the transcription of what I say. And we can see that right there. And then it will send it to the small Gemma model in Ollama, and it will take a little longer the first time that it gets sent to it. But once that's done, it will then take the response from the Google model here, and it will actually speak back its response.
Okay, I'm ready to listen. I'll do my best to transcribe your words as quickly as possible. Let's begin.
What is your favorite thing to do? And we can see currently it doesn't actually show the transcribed output from the LLM.
My favorite thing to do is to make everyone happy.
All right. So I muted the mic so it won't hear me, but basically we can see that this is actually, relatively speaking, in terms of like what is available in terms of lowest latency for offline local chatbots, it's quite decent speed, considering this is a $250 little AI supercomputer device, and everything here is running entirely locally. So I'm going to go ahead here and just go hardcore, and we're going to turn off our Wi-Fi, and I'll unmute my mic, and then, hey, there's no Wi-Fi.
Okay, that's a very simple statement. It's a common and understandable request.
And you can see it's working fine with no network, and then the actual face here is just kind of like scaling up and down, because that's how it's supposed to when speech is happening, just to give a little immersiveness, as I had said. So
cheerful robotic companion. Tell me what you need, and I'll do my best to help.
No, I don't even know if you can hear that because it's so quiet. All right, so basically at this point, and if you want to quit this, you can just do from within the terminal here. So click into the terminal window and just type Control and C, and it will shut down the application. And the same way to actually get it started up again is just ensure that you're in the virtual environment that was created, as well as actually in the directory for the RoboTest repository that we cloned. And then you just do Python and then main.py, and you can actually, if you type M there, just hit tab and it will auto complete the rest of it, because it knows like what you're going to be typing. And then it will just open again. So overall, congratulations, because you just made like a fairly like low latency offline AI chatbot on your Jetson. But beyond that, it's very fun, customizable, and expandable, I suppose could be said. So let's talk customizability. Let's say that you want to go ahead and change the voice to be something else. Fortunately, it is quite simple, because we have a complete, let me kind of zoom in on this. I do apologize, because this is a different monitor setup that I'm using for actually filming this, so my neck is craned like that. But this is an entire list of different voices that we can opt to use with this text-to-speech, and truthfully, changing them is really as simple as changing one single line of code just to reflect the new name of the voice that we would want to use this. So let's say that we want to use a British English voice, and they actually have the overall grade, or I would presume this to be like the quality of the voice. So let's just go ahead and try George right here. So this will be a British male voice in the name of George. And basically all we're going to do now is actually a little bit of like code editing, but it is quite simple. So let's actually just use the file browser for this. We don't need to use the terminal. So from within our file browser, let's just go ahead and go into the RoboTest directory. And once we're in here, let's go into the audio subdirect. Oh no, actually I'm wrong. We don't even need to go in there. So from in this directory, we see this main.py, which is the way that we actually began this program. So we're not even going to use like any fancy code editor or anything like that, because it is really quite simple to change this. So we're just going to right click this and do open with text editor, and we will see the actual Python file opened right here. Now, in order to change the voice, we can just modify one single line of code right here, which is located here in line 46, where we see TTS model equals Kokoro TTS, and then we have the voice string, or whatever you'd like to refer to this as. So we can go ahead now and just kind of change this to the copy pasted voice that we took for the British Mail, just like that. But keep in mind that you also need to have the quotations around it as well, or it will not work. And once you do that, just Control Save or Control S to save the file. And we basically just went ahead and actually changed the voice that our text-to-speech is going to be using. So if we now go ahead and just run our previous command, which you can just cycle through with the arrows as well on your keyboard up and down, we will see that we're going to get a new voice here when this actually does load in. Hey, hey, how are you? My mic was muted.
Okay, here I am. How are you, my furry friend? I'm happy to be here and ready to assist.
And just like that, we're able to change the voice. And really, it's extremely simple, and it's cool to have that level of customizability without having to really do a lot of intricate work, I suppose, in the back end. But even just doing something like that, I suppose, is a decent learning experience, and having this almost like catalog of different voices here and the ability to so easily change them is something that I really like about just like local AI and things like that. It's just, I personally find it rather enjoyable to have modifiable stuff like this. In the same vein, what if we wanted to go ahead and actually change the AI model that was being used in the back end of this? Currently, we have the very tiny Gemma 3 270M model, which is, in my opinion, probably the best option here because it provides the lowest latency, because it's very fast to actually generate its responses. But there are a bunch of other very tiny models, and we can go ahead and actually choose to use a different one if we want. So for this, let's just go to ollama.com, and kind of how we had this like catalog of voices right here, we can think of this as kind of similar, but we normally have to, okay, I have to apologize because this seems to be a new web. Okay, so when we go to ollama.com, we can click explore models, which is, I swear this didn't look like this yesterday, so they must have changed something, but I guess that's good. So this is more up to date. And basically from here, you can search for a whole bunch of different models. Now, this is kind of different from how we were able to just quickly see the different voices here, because all of these specific voices will work with the TTS we're using. This is not the case for Ollama. A lot of these models, or most of these models, are far too large to actually run on our Jetson, or even if they do fit, they're not going to be very quickly. So say, for example, here we have Gemma 3, which is what we're actually using. We have these different version tags, and these just denote the actual size of the model. So for this Jetson, if we're going to be wanting to run something in addition to the text-to-speech and voice activity detection and things like that, we're going to want to kind of probably stay with models like that are 2B or less. So like this 1.5B, this 1B would work. We can ignore this because that's not necessarily a... And then like the Quan 0.6B is a good option. However, it is by default like a thinking model, so it will probably start speaking its chain of thought, which on one hand could be entertaining, but on the other hand would probably get stale rather quickly. So my personal advice would be you can go and use like a Quen 2.5 if you want, as they have a 0.5B or a 1.5B. However, I would probably be doing a disservice to not just kind of show this. There we go. So these are Josephified family of models, or uncensored. Now, there is a Quen 3 option. However, because of the thinking mumbo jumbo there, I find that it is actually sometimes better for this specific purpose to just go for the Quen 2.5 model. And if we want the absolute maximum amount of speed, we can go ahead and use the 0.5B model, which kind of in the same vein as Gemma 3 270 million is a rather small model. Now, say we want to use this. First thing we're going to do is just click on the little like copy button right next to the specific version we want to use right here. And then from over in our terminal, we're just going to do Ollama run and then paste in that thing which we had just copied right there. And that will go ahead and download this new model to our device so that we can then go ahead and actually first and foremost just chat with it, but then implement the changes necessary in the code, which are very similar to how we change the actual voice. So with the model loaded in, we can do the same thing. We're like, hey, bro. And we can see our response is a little more unhinged, which is probably what one would want when using this specific model. But now we can go ahead and actually make it so our program will use this LLM instead of the Gemma one. So as we did before, we're going to just probably do this through the file browser, as it is kind of simpler, I suppose. And we're going to go back to our robo test folder right here. And then once again, we're going to open this main Python file using the text editor. And when we have this opened, we can go ahead and just scroll back, or depending on where it opens from, we can scroll down a little till we see right here where we have line 41, where we see a little bit of information about just the Ollama client integration here, or the ability for this to access our chat model or whatever you want to call it. And we see that we have the name of the model right here denoted under this model parameter. So we're going to want to change this Gemma 3270 to the model that we had just downloaded, but in order for Ollama to work properly using this, it needs the exact specific name that Ollama sees the model as, or else it will just not find it. So, you know what, I think first and foremost what we're going to do is, let's just put in the wrong name so we can get an example of what this will actually, so we can get an example of what the failure would look like, so we know that if we mistakenly had put something there, it is a failure. So let's just do this right here. And then once everything loads in, we're going to get an error here from Ollama, just basically like the model could not be found. Hey, what's up? Hey, what's up? Okay, so then we see, hey, this model named Gemma is not found, which is what's specifically listed right there. So you will just get that sort of 404 error if you incorrectly list the model. Now, the correct way to actually get the model is just type in terminal Ollama and then list, and then we'll see the different specific models we have downloaded here. And for our new model, we're just going to copy it in its entirety right here. And then take that and make sure we don't accidentally remove the quotations around the name of the model. And we'll paste this into our main Python script where it should go. Save it. And then if we run this one more time, we can actually now go ahead and speak with our newly downloaded uncensored Quen model, which I probably can't do much of on camera. Hey, what's up, buddy? And remember, we have our British voice now too, so. And this will be a bit slower for its responses than the Google model, being that it is.
On-camera tasks often involve capturing and presenting content, but the broad range of possibilities is limited by physical space and equipment capabilities.
It's quite insightful. Thank you, George. So, right there, we basically not only changed the voice that we're using, but we also changed the actual LLM that we're using to power the intelligence in the responsiveness of our chatbot. And again, this is designed to be very modifiable because it's more fun that way to be able to customize and tweak things to one's liking. In the same kind of vein as mentioning that, the only final thing I want to kind of touch upon here in terms of customizability is going to be line 43 right here in the script, where we see the system prompt. So currently our model is just set to act as what is contained between these two quotation marks. So you're a cheerful robotic companion speaking concisely. Let's go ahead and just kind of change that. Now, I struggle to do this in a manner with which I can still show on a public platform, so you know, you can have fun with this. So I've now just gone ahead and changed that so that it can act as a very angry robot, and we will actually see that our responses begin to change in tone to kind of adhere to the system prompt. Hey, how are you?
Hi there, I'm just a computer program. How can I help you today?
Okay, well, again, the smaller models aren't that smart, so they won't perfectly adhere to this, but it will act as you denote it to, assuming that the model doesn't have guardrails to prevent it from doing so, which this model doesn't. So, and again, I mean, if you find that it's lagging for a long time or something like that, you may notice that we had removed the concise instruction here, so it may be generating a rather long kind of response, which can just... So that's probably going to kind of wrap up the actual like technical or tutorial style part of this, at least in terms of just getting this working in a raw fashion using a computer monitor and the Jetson and just like a USB mic. Now, I suppose the next thing I will do is just kind of, I don't actually know. One of the last things I'd like to quickly touch upon is the differences in the ways that the faces are actually going to be drawn on screen, depending on whether or not you're going to use this just through a computer monitor in a desktop setup, or if you're going to use this on the robot. So when we clone the GitHub repository, we're actually going to see that there is also an images folder here. And basically inside this folder, there are two different sets of images. One to be used if you're going to be using this in a desktop environment, so basically through a computer monitor, and one set of images if you're going to be using this on the robot. And the orientations of these images are different to better work for either way. So the robot one needs to be like flipped and mirrored, and the desktop one obviously does not. So as we're on the desktop right now, let's just go ahead and click on that subfolder, and we'll notice that these are upside down, but just bear with me because it will make sense hopefully soon. So we're going to just drag these now into the RoboTest repository, as they need to be placed in this folder directly so the script can actually find them. Now, if we're using this in the desktop, there is one single change that we're going to need to make to the main.py script. So we can just open it with the text editor right here. And if we scroll down to, oh, okay, good, it's already selected, line 29 right here, we're going to see the rotation degree value is set to 180. For the desktop, we're just going to want to set that to 0 and then save this file. And once that is done, we can actually go ahead and just run our application. Actually, no, we can't, because there's one other thing that we need to do as well, and that is actually modify the face animation script right here. So if we go into the face animation subfolder and open the face Python script right here, we're going to see that these are a bunch of different settings for basically like the coordinates that the face and mouth are drawn. And we're going to see right here, we have two lines. So basically, if we're using this on desktop right here, which we are, the coordinates, and this is kind of where the mouth is like located on the actual face. So we need to have this line active, which is just setting the mouth coordinates for desktop. So we will just go ahead and remove the comment right there to make this line kind of like active unscientifically. And then beyond that, if you were using this on the robot, you would just keep this line commented, and you would then go ahead and just uncomment this line right here, as well as something else which I'll show in 1 second. But being that this is on the desktop device, we want that line uncommented, and we can now close this, and all of the edits that we need are made for this to work on the desktop, and then we can run our application. And we see that the mouth and face are actually like shown up properly here. And then obviously you can change these as you see fit, and the mouth just scales up and down as it speaks. So it's not really like very technically complicated, I guess could be said. Now, in the event that you are going to be using this onto the robot, obviously this image is the incorrect one, as well as that mouth image for the robot, as those need to be kind of slightly differently oriented, basically because the robot's projector mirrors and flips the images. So in the same way, we would then just go into the robot subfolder instead and drag these two images to the top level directory here in the RoboTest folder. So just like that. And basically it's the same thing that we just did right there, except we just put the images for the robot in this folder instead. And of course, the thing we would need to change in that point is go back into the main.py Python script, and we would put the rotation degrees back to 180. And then we would also go into the face animation folder to find the face Python script. And then we would also go ahead and comment the line here for the desktop, because we're not going to be using that. We'll be using the robot now. And then we uncomment the line for the robot orientation and save that. And then we'll see that once we actually run the script here, we'll see the face totally sideways and things like that. But this is actually the correct orientation that this needs to be to properly display on the robot's like projected face image. So with that, we're almost basically if you are not building the robot, this is essentially the conclusion, and you can kind of just close the video now and go have fun and play with this, because that is the extent of the actual kind of setup steps here. But if you are opting to actually go ahead and build the robot, there are a few other things that we're going to want to do just to make sure that once the Jetson's actually mounted in the robot and we can't really easily like navigate around the desktop using the keyboard and mouse, we want to still be able to remotely control it. So for that, we're going to be using SSH, and we need to first enable that so that we can kind of remotely connect to it from a different machine on our local network. For this next step, we're going to need to first get the actual IP address of the Jetson that we're using right here. And the simpler way to do it is to just go into the settings application, just like this. And from there, we will go on to Wi-Fi, and then we will click settings, just like that. And then when we see this information, our interest right here is in this IPv4 address. So we make note of ours, which is that in this case, which I will just go ahead and copy. Our next step now is to actually install and enable just kind of the ability to have this act as a device that can be remotely accessed. So to do that, we're just going to type sudo apt install and then open SSH-server. I definitely made a mistake right here. Open SSH. Okay, so I put an extra S, so it's just going to give me an error, but that's okay. So we'll fix that real quick by just removing one of these erroneous S's, and then it will go ahead and ask us if we want to continue, which we do, and we'll just let it finish. And once that's done, we're just going to check the status and see if the service is now running. So we're going to type sudo systemctl status and then SSH. And when we press enter right there, we'll just see like some random slop right here, but basically that just means we're all set. So you can type Q to kind of get out of that. And then basically we just want to keep note or write down that IP address of the device that we had jotted down. And the next step is actually basically we can shut this Jetson down now, because we will be able to do all of the other steps, including actually now physically placing this into the robot through SSH remotely from a different system. So that's our next step. Our first step is to just make sure that we have the Jetson post properly installed in the robot. Following that, there are 3 clips that will hold the Jetson into the robot just to make sure it does not fall out. The 2 front clips are, I would suggest, to be glued on, as they will just hold better that way, and you can still slide the Jetson in and out with those glued in. The 3rd clip that goes in the bottom needs to not be glued or put securely on, as removing that will allow you to slide the Jetson out of the robot, and you want to make sure that you have that option. So once the Jetson clips are glued in the front, our next step is to just take the Jetson and go ahead and slide it in, just making sure that the lip of it goes underneath the clips in the front, kind of how we see here in the video. Following that, we can put the bottom front clip on just to make sure that it will stay in place properly. Once that's done, our next step is just going to be to plug in the DisplayPort to HDMI adapter, and then plug in the small 12-inch HDMI cable that is connected to the robot's projector to the adapter from the Jetson. Once that's done, we can plug in the Jetson's power supply, and keep note that it always kind of looks like it's halfway plugged in, but that's just kind of how it is. So if it looks like that, it is actually properly inserted. Then finally, our last thing to do is just go ahead and plug in our USB microphone to the device, and that's essentially the entirety of the steps that are required for physically installing the Jetson into the robot. Now that the Jetson has been physically installed into the robot, the next steps are going to be specific for the use case of this with the robot. Now, one of the limitations of having this in the robot is that we can no longer really use a keyboard and mouse to actually navigate around the graphical user interface and perform actions. This is just because the projected image is mirrored and flipped, so it basically would be rather difficult to actually use a mouse through that, and it would just feel very uncomfortable. So with that, our next step basically is to first and foremost connect to the Jetson using SSH, which we have already gone ahead and enabled on the device itself. So really the only prerequisite for this right here is that the Jetson is physically installed into the robot, it is powered on, it is connected to the internet, which it should be if you followed all of the previous steps. In addition to that, we want to have our USB microphone plugged in, and the actual HDMI out is going to be just connected to the robot's projector. assuming all of those prerequisites have been met, our next step is now to go ahead and actually connect to the Jetson remotely from a different computer using SSH. Now, I am here on a different computer, and I do want to make a very important note that they must be on the same network. So the Jetson and the computer that you're going to be using to remotely connect to the Jetson have to be on the same wireless network for this to actually properly function. But assuming that has been correctly taken care of, and it very likely is something that just will be the case, we can now go ahead and from a terminal window on our separate computer, go SSH, if I can type that correctly, SSH, and then our username for the Jetson, which in my case is just OMNS, and then and then the IP of the Jetson that we got when we actually looked in the network settings and jotted it down to actually prepare for this step. So in my case, it was 192.168.50.214. And once we do this, our system will basically, depending on how you have this set up. So I'm using this through Ubuntu. If you're planning to use a Mac or a Windows computer, it may be a slightly different visual experience here, and you might need to configure things differently, but I unfortunately can't speak to that, so I do just want to make note of it. But in the Linux scenario here, it's basically just doing security conscious things, asking us if we want to continue with this connection, and I type yes, and then it prompts me for the password for the username we entered for the Jetson, which is just my default Jetson username. So I will enter the password for that right there. And then we can see that now our terminal has actually changed to that of the Jetson. So if I just try to type ls, which will list the files, we see that we now have the files from our Jetson right here, including the robot test directory from which we will be working inside of. Now, once we're connected through SSH, the steps to actually go ahead and launch the application are almost exactly the same as if we were using it just through a desktop monitor. However, there are a couple of special considerations that we need to accommodate for, being that we cannot use the keyboard and mouse to actually click things or change settings on this device because it's installed in the robot. So the first one of those things, and this may be something that does not happen, but just in case it does, I want to get it out of the way first and foremost because it can be quite annoying. If the system software updates window appears and it is installed in the robot, it is quite frustrating because you can't just use the mouse to X out of it. So fortunately, we do have a simple way to go ahead and remove that, and mine is actually experiencing that right now. So with the robot in front of me, I can see the software update window has appeared and I want to get rid of it. So fortunately, if we scroll all the way down here in this repository, we can run this command right here from through our SSH connection. So remember, this is essentially running this command on the Jetson itself. And when we do this, we're basically asking it to tell us the process ID for that update or software update pane. And that way we can actually use that to close it without needing to manually use a mouse or anything of the sort. So we notice right here that we have a few things, and for our purpose, we're just going to pick this first number right here, which is the process ID of the update notification. And once that's done, we're just going to type kill and then paste in that process ID right there. And when we press enter, it should go ahead and just kind of get rid of that actual software update screen in the event that it doesn't. So I am going to try this one as well because, to be honest with you, mine has actually not gone away, and I notice sometimes I have issues with this. Okay, so it was actually the second one right here. So just in case that happens, it will be a different process ID on your system and the names might be slightly different, but I did just want to get that out of the way as it can be an extreme annoyance with no simple workaround where, like, if we were using it through a desktop computer, we could just click X and close it. The next of the robot specific things we need to go ahead and take care of are actually setting the default output for sound and the default input for microphone. So in the desktop, we could basically just right click on the top and go into settings and set them that way. But with it physically installed into the robot, we do just have to do everything through SSH. And fortunately, it's not very difficult to do that. So first and foremost, we're going to take care of setting the default audio out, which will just be through HDMI. To do this in the repository right here, we can go into this setting and then just copy and paste this command into the terminal SSH session. And this will basically go ahead and list the potential options we have for our audio out. And in our case, we see that one of the ones we have available is the HDMI stereo, or just anything that says HDMI, as that is how we are going to be using it in the robot's case. So the next thing to do is basically, and I suppose I should probably expand this window for right now. I do apologize for that. It will show us a list just like we see right here. And then we need to make sure that we find the one with HDMI. And then we run this command right here, followed by the actual specific HDMI device name that we have shown here. So for this, basically, I'm going to paste the first part of the command right here, which is just basically saying set the audio output device as, and then we need to just paste in the name of our specific HDMI output, which in our case is this right here. So then we're just going to paste that next to that command and press enter. And that will go ahead and set our default audio output as HDMI so that it will actually just use the projector's internal speaker for the robot's voice. Or if you connect a 3.5mm audio output cable to the projector and that to a speaker, it will just kind of pipe through and use that instead. So there are a few different options for audio out on the robot. Now, in a very similar fashion to what we just did, we're also going to need to set our default input device, which in our case is a USB microphone. And in order to do that, we're going to run this command right here, which is almost identical to the first one, except instead we're asking it to list the available audio input devices or source devices. And when we press enter with that, we're going to see, depending on your specific setup and what you have connected, a bunch of different options. But what we are looking for, and the specific one in my case, is this input of USB, and then this is just the actual name of my specific microphone. So the same way is going to be used to kind of set that we did previously with audio output, where we just copy this, set default source right here, paste it in, and then we're also going to just copy the actual entire name of our default microphone source, which in this case is that line right here, and then we will paste that next to that, and you may see that I accidentally neglected to put a space between it, so we'll just do that, and then we'll press enter, and then our default audio out and our default audio in have been properly set up. So we're now good to go ahead and actually be able to use those devices without having to deal with like a keyboard and mouse or setting anything like through the graphical user interface, which obviously is not possible with the robot. So our next step now is basically to just go ahead and kind of follow some of the original steps we did here when we were actually setting this up. And mainly that is just going to be actually activating the virtual environment that we had created to install all of the dependencies from inside of. So we can see we're now back in our virtual environment. And then the next thing to do is just go into the cloned directory for this GitHub project, which maybe a slightly different name than RoboTest when it is actually out there in the world, but all of the steps will be identical and properly listed right here. So from this repository, our next step is basically to go ahead and just do python main.py, which will run and start the application. Now, before we go ahead and start the application, though, we do actually need to run this command right here from within the SSH session. And basically, if we don't do this and try to run the app, it will not actually ever show up on the robot's projector. Because we're starting it through SSH, it's not as direct, I suppose, as if you had it hooked up to a desktop computer where you were physically working on the device itself. That's probably a bad explanation. But basically, we're going to paste this into the terminal right here before we run the app. And if we don't do that and we run the app, we'll just actually never see it show up on the robot's projected screen. But once this has been done, we can then go ahead and just actually run the app right here, which will go ahead and run everything on our robot. And after a few seconds, it should go ahead and properly show the face image on the robot and things like that. Now, I am seeing the one that I'm noticing right here is unfortunately upside down. So that is kind of something that I will need to tweak in the repository, but we did also look at how to actually change some of the orientation values depending on the specific face image we're going to be using. So it would be, as you may recall, since it's probably just a few minutes ago in the video where we actually modified this, we could just go ahead and do, and in this case, since we're from a different computer, we can type main.py with nano in front of it, which is just a built-in terminal text editor. Oh, interesting. So we don't actually have nano installed on our Jetson, which you probably will if you followed my full hour-long Jetson setup tutorial. So just pretend that that opened. So with the actual script open through Nano, we can just go ahead and actually change the line here for the rotation as we did prior in just editing this on the actual desktop when we first set it up. So I'll just instead change this from 180 to 0, and that should probably remedy the specific issue I'm having where it is just showing an upside down face. So I'll try running this once more. And again, it is just kind of the nature of this that it's rather experimental and customizable. So depending on your face images or the scale of such, you may need to go ahead and kind of modify those values. But fortunately, that does work perfectly. And the robot's face is actually staring at me. We won't hear it talk or anything like that because I don't actually have the speaker plugged in and turned on. But the only other adjustments really here are actually physical adjustments of the mirrors, which are built into the robot. So you can actually move them up and down for the top mirror and then up and down as well as tilt side to side for the back mirror, just as it was easier to be able to manually adjust the picture and then have to do finite like X and Y changes to get it perfectly aligned. So, okay, we can see that it is basically, I can see its mouth moving right now. And one of the downsides of this video is I'm not going to show as much of the robot actually like talking and its face on screen, because especially with bright studio lights pointing at it, it is very, very difficult to see. But it just works better in a lower light setting, which obviously does not correlate with proper video quality. So with that, this is actually the conclusion of how to actually set this up and get it running on both just a desktop with a keyboard, mouse, and a PC monitor, or from within the actual robot itself, if that is something that you choose to want to go ahead and either build or just purchase like a pre-compiled kit as a bring your own Jetson style thing, which I will of course have available, and I will put a link to those as well on the GitHub and as well on my site. So basically, that may actually be the conclusion of this video. I hope that this was useful and something that will inspire folks to go ahead and actually build some fun and entertaining things with these Jetsons. And the whole concept or core of this was just a customizable and relatively speaking low latency and fast offline capable chatbot that has voice activity detection, some customizable voices, and a somewhat customizable personality, whether it be the actual LLM, the system prompt, or the face image that's used for the robot. So that's going to wrap it up. If you have any questions, please feel free to leave them in the comments. And again, the GitHub repository will be named something probably slightly different than RoboTest here. Maybe I'll just leave it like that. I don't know. But if you also have any questions about this, you can actually open an issue from within GitHub here in the Issues tab. I will make note to actually keep an eye on these. So if anyone has any specific software questions or problems, please feel free to leave them in this repository as well. And I will likely see this more likely than I would in a YouTube comment. So with that, that's going to wrap it up, and thanks for watching.